All right, so let's take a look at sine and cosine of complementary angles. So here's our angle theta. This is our reference angle. Just ignore this part for now. Just for now, we'll bring that back in and what that means. It is going to have something to do with complementary in a second. But if this is your reference angle theta, let's just think sine of theta. So sine of theta would be opposite over hypotenuse, right? So opposite side would be here. The hypotenuse would be here. Okay? So let's just say if this side was, let's just say hypotenuse was 15, the opposite side was 7, then sine of theta would be 7 over 15, right? Opposite over hypotenuse, opposite of theta over the hypotenuse. Now, here's the main thing that you need to understand here, that you can create, and you probably have already seen this, you can create the exact same ratio using cosine of the other angle. So cosine of that angle, whatever that angle is going to be adjacent. So if we're now talking about this angle, and remember this was, we said this was 7. If we're talking about this angle, this is now the adjacent side over the hypotenuse, which we said was 15 earlier, right? So in this case, that would create the exact same side, right? Now, what would we call this angle? Well, we know there's 180 degrees in a triangle, but in a right triangle, it's always 90 of it's going to be taken up by here. So 180 minus 90 leaves us 90 degrees to split between these two angles here. So this is theta. If this was 50, then that means that this would have to be 40 degrees because they have to make up 90, right? If this was 73, then the other one's going to have to be 17. They got to add up to 90 because the whole thing has to add up to 180. So what's the general way we can say this? Well, if there's just some generic theta, and doesn't matter what theta is, right? If like 73 is theta, then 90 minus 73 gives you the 17. 90 minus whatever theta is going to always be this other angle. And that's why this angle is 90 minus theta. So let me just kind of clean this up a bit. And I probably should, let me put this in a different color. So in reference to theta, we have the opposite over the hypotenuse, which is the same in reference to 90 minus theta, adjacent over hypotenuse. So what we're getting at here is that sine of theta equals cosine of 90 minus theta. And the same thing goes the other way. You can, flip this around and just say, hey, cosine of theta is going to be the same as sine of 90 minus theta, because cosine of theta would be adjacent. It would be here now if we're talking here, cosine of this. Adjacent of hypotenuse would be the same as sine, which would be opposite of hypotenuse. So give us the ratio of the same two sides, right? That's the main thing here. So we can also write that. Let me just bring this up, and then we'll take a look at some problems. So basically, there's multiple ways that you can solve for a missing value. So if we look at this one, which expression represents the length of side BC? So BC is this side, so let's call that X. So we have a reference angle of 55, so using that 55. So you can see there's going to be multiple ways of doing this. So we have to find X, we could use tangent, but I'm going to look at the multiple choice. There's no tangent here because opposite over adjacent, but I do see cosine. So let's use cosine. So we have adjacent over the hypotenuse. So cosine of 55 equals X over 6. Multiply the 6. So X equals 6 cosine of 55. So that's one of them. Now, how are we going to use sine? Well, what's the other angle? It's 90 minus 55, right? So the other angle is going to be 35. So we could use that And we'll do the opposite over the hypotenuse for this one. So sine of 35 is x over 6. So if you don't remember how to set these up, go back to the other section, and it's all that SOHCAHTOA stuff that we did. Didn't like this arrow, so I want to redraw it, and that's much better. X equals 6 sine of 35. So pay careful attention to the angles there. This one's a little more interesting. So which expression represents the length of side KL? So KL is obviously going to be the missing side here. We'll call this X. So trying to find X. Notice all these are in terms of sine, and we're going to choose 2 answers. I think the other one specified 2 answers as well. So finding X, well, if our angle is 60, we could say sine of 60 equals the opposite over the hypotenuse. And so if you go back to the previous lesson, you'll see that solving that will give you 5.2 over sine of 60. Let's see if we can find that. And here it is. So that's one answer. Let's take a look at the other. So this other angle, notice they're keeping it as 90 minus 60. We know that's 30. We know this is going to be 30, but the same thing is 90 minus 60. It's just taking that idea earlier that we saw, the whole, 90 minus theta idea. And so using that, we could do sine of this angle, because this would be opposite over hypotenuse. So sine of 90 minus 60, honestly I'd put 30, is going to be 3 over x, which gives us x equals 3 over sine of 90 minus 30. And there you go. Let's see, this one might be a little bit different. Which expressions are equivalent to cosine of angle M? So good thing I took a look at this. So here's angle M, here's our reference angle, which is adjacent over hypotenuse. So we want to find things that have that same ratio of adjacent over hypotenuse, of these two sides. MO over MN basically is what we're looking for. Oh, look, good thing I wrote that out. MO over MN, that's good. Length of side opposite to N over the hypotenuse. That actually looks good to me. Here's N, opposite of N would be the same side as the adjacent to M, right? So that actually works as well. Over the hypotenuse, that sounds good to me. Tangent of N would be opposite over adjacent. That would be using this side. And then NO over MN. NO, we were also not using that side, so that's not good. So good thing I looked at that one, because that was a little bit different, but still the same idea. That's a really good problem, that one there.